So if we can be on the same page in terms of computational participation, how do we go about not just broadening, but also deepening it? So I think about deepening participation along 3 lines. I think about access, obviously, is important, but also think about deepening the kind of activities in terms of programming, and also that these communities actually are the rich and welcoming places which they are supposed to be. So let me start with the first one, access. And so there's obviously a lot of efforts, especially in the United States, but I know also across the world, of different groups who have now taken it upon themselves to create access. Girls Who Code, Black Girls Who Code, Google made a nice video to showcase what girls can kind of make with code. And I think it's important. I was actually very much against the girls only arrangements, but nowadays, since the situation is so dire, we actually need to kind of have multiple access points, whether it's in schools or communities, after school centers, or online. We really need to look at the whole spectrum. We can't just have one access point. So these interventions, these organizations do play, and related ones, play a critical role, not just in broadening, but also deepening access so we can address the lack of diversity and equity. Furthermore, I think we also need to be concerned with participation in communities like Scratch. So yes, there are, let me just pull out, and I know the numbers are not exactly up to date. So you see actually over the last 6-7 years how dramatically the number of projects as well as participation and participants has kind of grown from just a few. We have now, I mean, over, we probably have more than, after the hour of code, more than 7 million participants, and I think 12 million projects, and I don't know how many comments. There are many other examples, through the Looking Glass, Kodu, where people actually have taken on not just to create the programming tool, but also the community. But then the question comes up, who is really participating? So we have great success stories of kids who go online, who collaborate, who make things, but how broad and deep is this participation really? So I was able to get access to the back-end data because I was part of the Scratch team. So we tried to kind of, so what we did, we took a random sample from people who logged in the end of December 2012 of 5,000 users. They were doubly random. There's about 30,000 daily logins of unique users. So we took 5,000 randomly from them. And then we looked at what those kids were doing. But this is kind of based on the data which we could collect. And here you see a distribution of who is actually online. And what you see is actually interesting, that about 1/4 of the users are really new. So that's just kind of, but there's also 1/4 who have been there a long time. So you have a healthy mix of old-timers and newcomers if you want. When you look at what people are doing, the picture starts looking a little bit different. So of those 5,000 users, over 55% never posted a project. This was, by the way, the old Scratch version where you had to download or upload the software, you were not online. But then 45% did. So we cannot say anything about those browsers because the system doesn't keep track of the way we had access to the data on what they were doing. But we can say something about those creators, the people who were there. And what we found when we looked at what those creators consist of, we see kind of different types of participation. People who just do a little bit of everything, some people who download a lot of projects, people who comment, And then people who do networks, they comment, they download, they put up projects. And then of course we have that group of high networkers. They're kind of heavily engaged in everything. And if you look over a 3 months time period on how this participation shifts, this is the kind of image you get. And what's really, I know this is, I'm not going to bore you with the details. This is latent class analysis, which kind of tries to determine the probability of how people fit into certain categories. And you know, we try different models, and this was the model which created the best fit for the data. And the one thing which you really can see, again, remember, 55% of the people don't leave any traces, we don't know. From the 50%, what we see is that the high network people who do everything, they get even more productive over time. So what this indicates, if you are heavily involved, the likelihood of you being heavily involved in the coming months is very great and is going even to increase. But for the other parts, we actually see that it's much harder to shift from these kind of low network peripheral forms of participation into the more active forms. So what can we do? I mean, what do we need to know in order to help kids to kind of move from the periphery, from the browsing and lurking, if you want, into higher forms of participation? So one thing we looked at all the projects which the kids had posted. We didn't run them or anything. We just coded them for loops, Boolean operators, broadcast, and variable. We did some other studies before. These were important concepts. We looked for the presence of these concepts in their program. Remember, this is big data analysis. You don't study individual programs. And we looked on how the use of these concepts is distributed. And what you see here, looping is pretty popular. And that's also the largest class of users. And then come conditionals. And then the rest, I mean, things like Booleans, roughly everything. But what you see among the classes is that the kids who do everything, even the concepts which are not popular, they're kind of very heavily used. But the kids who are just, I mean, in the broad class where people are on the periphery, they hardly use any concepts. So we see some very differential use. And I realize this is a very rough measure of kind of assessing program complexity. You can do obviously more. And Debbie is actually working in a grant, in a different grant, on trying to not just look at better measures, but also to hook it up to actual programming performance on how those programs are created to understand better why kids use certain things. And this doesn't shift much over time. So we know the high networkers are the people who always do a lot. So what we have is a large group of people who are beginners, and then get to do some loops and some other parts, but not Boolean variables. And then we have intermediate and a relatively small group of experienced kids who kind of do a lot. If you look at this in terms of remember how long people have been online, you will see that, I mean, the likelihood of somebody who is experienced, they will also use more of the sophisticated projects. That's probably not that surprising. We wouldn't expect differently. Kids who have a lot of experience probably also get to use more concepts. But we do actually see some gender differences. We do the same analysis. Ethnicity is not tracked in Scratch. People don't report on this. And what we find in the beginners, we have approximately, the girls are more likely to be there. And in particular, if we look at class 4 advanced, we see a big gender divide. So the reason why this is interesting is when you go onto the Scratch side, and you can go on right now, none of these things are really apparent. And even the people who designed Scratch Mittel's book didn't know them. You know, you have to do these kind of tools to understand, is computational participation in a community like Scratch equitable? It isn't. And it is obvious that it's very hard to move from these kind of beginning stages into the more experienced advanced stages. There is a kind of invisible hurdle where the kids get to participate, where they can reap the full benefits. And I'm not doing this analysis to kind of, ditch Scratch. I'm just going to show it's great that we have these online, freely accessible, they come free of charge, you don't have to pay. But just because there are so many kids, it doesn't mean that everybody actually goes and participates. And it's not something you would be able to see when you go onto a front page if you spend a few hours. It's even not visible to the people who run these communities. So deepening communities, I'll just kind of skip this. Deepening these communities is important. And the reason why I bring this up, because if we do programming by choice, you decide you want to do in Scratch, we know that it's hard to get in and to participate. We also know that the girls, they're actually about 45% of the users. It used to be only like 1/3, but participation numbers have increased. But we know when it comes to the more sophisticated part, girls aren't equally there. And then in terms of equity, what we see, it's the top 5 or 8% who engage very heavily in all parts. And the reason why I bring this up, when we introduce programming in school, I think we actually have an opportunity to address some of these challenges. It doesn't happen on its own. Just by making it available, not all the kids will go there and not all of them will develop expertise on their own. We need to support scaffolding and introduction that schools and other places can provide. And if we are at the topic of school, the last category is deepening activities. So programming in grades is great. Hey, I proposed it first, and there are millions of kids who now program games, whether it's in Scratch, Kodo, Alice, you name it, learn programming. But I don't think that's the only way you can learn programming. And we all know from the recent incidents, gaming and digital cultures are not very welcoming cultures to girls and many minorities. So why should we use something like this? Likewise, robotics, great activity. It's one of the few things which is actually fairly well established in schools and especially after-school programs. But we also know, the recent research by Brandeis University shows that at best 1/3 of girls participate in these competitions in robotics designs. So I think if we really are serious about bringing programming back into schools, we also need to think about a richer array of activities to come. It's like in English, if you only were to read Shakespeare, of course you would get a great experience, but there's much more different types of books to read. And likewise, there's many different things of programming to code. And one area in particular I have been working with and others is electronic textiles. They're kind of the counterpart to robotics, except they create soft, wearable things. So you use the Lilliput Arduino invented by Leah Weekly, and you use conductive thread to stitch circuits, and then to connect sensors or actuators like LEDs to the Lilliput Arduino, which has a microcontroller, and you can program actions as well as interactions. You can use conductive fabric. And Leah invented this about 10 years ago, and it was a kind of cute activity to bring sewing, crafting, and coding together. But nowadays, I don't know who of you has an Apple Watch or a Fitbit. Wearables in the last 1-2 years have actually become really popular technologies. So like robotics, which leads into manufacturing and other areas, I think for wearables, we also now have a pathway which is not just about cute things, but also something which actually is an authentic device. And I think in particular, looking at the history of computing, where many argue that Ada Lovelace was actually the first woman the first programmer was a woman who wrote a program for the analytic machine designed by Charles Babbage, and she compared it actually writing, programs for the analytical machines to the weaving of leaves of a textile loom, for which, people used the first program. So textiles were actually at the origins. And just to give you an example, we actually use this at the recent hackathon, which is another great male-dominated domain, coding competitions. In case you don't know, you probably wouldn't go there. It's a place you go for a weekend. You don't sleep, you don't shower, and you confess your love of coding. And PanUps is actually the world's largest hackathon, twice a year, or one in each semester. Over 12 to 1,400 undergrads from all over the world come to code. And I noticed that in PanUps there were very few women who participate, which is kind of strange, because in 2008, when it was created, it was specifically created to bring women into computing. Well, that did obviously not work out. So within PanUps, we created a separate hackathon called StitchFest. And we invited people to use the LilyPad Arduino to design variables. And here you have one of the winning designs. This was when Flappy Bird was a game, some of you might know that. And you had a wearable controller. So by weaving your arms, you could actually navigate the bird on the screen. And it's an interesting change, because the winning design of PanUps, you will appreciate, it was a math homework machine which somebody designed, which not only would read the math problem, but it would also handwrite the answers. I think some of those students had very hard feelings towards their math classes in elementary school. And it looked, it actually was a very beautiful design, but it looked very different from the kind of variable designs like a onesie, which kind of checked the body temperature of a baby, a music sleeve. And it's just to show that we can design rich computational artifacts, but they don't all have to be in robotics or in gaming. They can also involve textiles and other materials. And lo and behold, we actually managed to double the number of women who came to our particular hackathon. And I think it's very comforting to know that we can have functionally equivalent computational construction kits, which just make different things, which tap into different activities, cultures, and communities that can help us not only to broaden, but also deepen participation. And the reason why I do all of this, and by the way, I did go to bed during the PanUps hackathon at midnight. It was over for me, and I came back the next morning, because I think that the digital public we all live in right now, because you use your technologies not just at work like it was 30 years ago, you use it at home, you use it actually even when you drive your car, no names, anytime, anywhere when you travel, is now the new public we're living in. And I draw an analogy to urban planning, because 30, 40 years ago, many urban cities kind of became destitute, and people realized if they wanted to make those centers and any actually destitute place a living place again, they not just needed to involve developers who wanted to kind of turn a quick buck, but they also needed to bring in the people who live there in order to make it a place. And I think likewise, for the digital public, for people, for kids to participate, we also need to provide them the tools to facilitate this participation, because otherwise only certain voices will be heard in who gets and what to do in this digital public. Thank you very much.